All right, so the last section that we're going to deal with is part of Chapter 5, is Lesson 5-6, and we're going to deal with simplifying algebraic expressions. And when we get done, one of the things that we need to be, or that is what your target is to be able to simplify algebraic expressions as far as they will go. In some cases, I will tell you ahead of time, is there may be some expressions that you will not be able to simplify further than they are already given to you. Okay. Now, in order to do that, again, quick review, 7x, when we have an expression, this is a very basic, simple expression. It is an algebraic expression because there is at least one variable. And so in this case, x is the variable. And the 7 is that thing that we call the coefficient. And the coefficient is the number that is multiplied by the variable. So in this case, 7 is the coefficient. It is being multiplied by x. The one thing that we should talk about at this point before we go any further, though, and you may want to add this to your notes off to the side or something like that, is in the event that you are given a variable, and I'm going to go ahead and just write over here in this empty space, but like I said, you may want to go write it off to the side on your notes paper, is that if you are given a variable, let's say, I'm just going to pick one, g, and there is no shown coefficient, we are assuming that that value is a 1. Okay, again, this is another mathematical shortcut. You know, as we talked here, we don't have a space here between the 7 and the x. So we are assuming that as a mathematical shortcut, we're saving space. We don't want to put the x or the x for multiply in because, one, we don't want to confuse ourselves. Is it an x? Is it a variable? Whatever. That and it shortens up problems to not have the multiplication. We do the same thing with coefficients. If there is no coefficient, if it's not shown, assume that it's a 1. Okay? So anytime you see it, a variable without a coefficient, assume that there, and if you want to, you can go ahead. You can write the 1 in there if you want. If you prefer to have it, go ahead and put it in. It won't make it wrong. So now, and this is how I like to begin the little presentation on simplifying algebraic expressions. You have a little brother and sister. They have been trick-or-treating and collected 3 types of candies, and you are now helping them try to sort out the bag by type. And we will represent our types by letters. Apples will be A's, bubble gums will be B's, and chocolates will be C's. Okay, so we have our A, B, C to represent the type of candies that we have. Okay, so now here's my candy and my bag. You see the bag's been dumped out. I am going to go ahead and sort these out by type. And I will try to put them in and see what I grab. And I may have to sort of sort as I go along. And chocolate, another chocolate, apple, gum, chocolate, gum. And so I am simply, and this is similar to what we're doing when we're talking about simplifying expressions, is when we simplify them, we will in essence be sorting them out by type. Okay, so now I have them sorted by type. I can go ahead and I can write an expression for them. And my apples in this case, my candied apples, I have 1, 2, 3, 4, 5 of them. So 5A will be my expression for candied apples. But in the bag I also have bubble gums. You'll notice I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 B's, 8 bubble gums. Okay. Or also in the bag, so on top of that, so I should add because I have other things. And the colors that I'm using here are not important. I'm just using a different color. 1, 2, 3, 4, 5, 6, 7. 7 C's for chocolate. Now also understand that it doesn't matter what order I write these 3 things in. Had I changed this around and put the 5A over here and the 8B over here, let me go ahead and even go a little further. And one of the little tricks that I can do with this particular machine. Same thing. Okay, the order of addition does not make a difference. That was the commutative property of addition. It also applies to variable expressions. Okay, so what order I put them in is not that big of a deal. Okay, so now we're going to go through and we're going to talk about simplifying expressions, combining like terms. Okay, now the directions. First of all, you need to sort by the expression, the terms by the same variable raised to the same power. I'll show you how to do that here in a second. And then we're going to add that. Once we've done that, we're going to add the coefficients together. Now, in this particular example, I've done them by number tiles. So what I'm going to do is I have all of these terms on number tiles, and I'm going to sort them out by letter, by variable, and same power. So you'll notice here I haven't put the 6x and the y squared together. Actually, let's do this a little bit more organized. Okay. You'll notice now I'm putting 2 and 14 together. Why? Because they don't have a variable at all. Okay. 7y. Now, y's. Same variable raised to same power. Yes, these are the same variable, but they are not raised to the same power. So I'm not going to put them together. I'm going to stack the things that are the same on top of one another. So the 2 and the 14, those go together. Okay. 4.5y squared. Well, y squareds go with other y squareds. Same variable raised to same power. X's. Okay, so the x's go together. There's another y squared, and another 5x. So now you'll notice here I have sorted the tiles, the cards, whatever you want to call them, out by variable type. Again, same variable raised to same power. So now my next step is to go ahead and simplify this to the end, is add their coefficients together. Alright, so my x's here, I've got 6 and -8, well that's -2. -2 plus 5 is just 5 minus 2, so that's 3. So this part here is 3x. So I simply put the x's, the things that are x's together, and then I added their coefficients together. Okay, my y's here, I'm going to get this so I can see them a little better. These are all positive, so I should be able to just simply add all of them up. All right, 3 plus 4.5, well that's 7.5. Plus another 6 is what, 13.5. So I've got 13.5 y squared. Okay. My y's, well, I've got -7 and 4. Well, that is a negative, or a minus 3y. And then 14 plus 2, I'll just put those together. 14 plus 2 is 16. Now, so those are simply, all I've done in that case is I've taken them, I've organized them by type, and so now my expression, well, I don't have an expression, I guess at this point, I have just separate expressions. But those are the steps that I go through to simplify each part. Now we need to go through and simplify entire expressions. Okay, so what I'm going to do, same thing, same variable raised to the same power. So you'll notice I have x to the third here, and if you want to, I'm going to go ahead, in this case, I'm going to circle my x to the thirds. All of my x to the thirds go together. So 5x to the third plus, this plus goes with, I should have probably circled the plus, it goes with the thing that follows it. 7 plus 5 is 12, so I have 12x to the third. That's part of my expression. Now, those are done, so I'm going to cross those off so I know that I'm done with that. Because I dealt with x to the third, I'm going to go to this other x squared, or this other x here, this x squared, and I'm going to do it next. Now you'll notice here, I'll circle it in green. Now the minus goes with it because it's the symbol that it's going to go with it in this case. You'll notice I have no other x squareds. Okay, so I don't have to worry about adding or subtracting it with any other x squareds. It's already done. So I'm just going to bring it down as part of the answer. And now we are done with it. Okay. Then, in red here, positive 3y, negative, because I'm going to treat that as a negative. So 3y minus 2y is a positive 1y. So this will be plus. Now, if you want to put a 1 here, you can. You don't need it. Now the other part of this is I could have switched the order of around of these things. I could have put the 1y in the front if I wanted to. I could put the negative 4 minus 4x squared in the back if I wanted to. But in this particular case, I would need these three terms. 12x to the third is a term. Negative 4x squared is a term. Positive 1y is a term. I need all three terms, but the order of those terms doesn't make a difference. The only thing that really matters in this case is this minus better be in front of that 4x squared. So, all right, B. This one is a little simpler because I've got x's. Okay, fine. X to the first power, x to the first power. Go ahead and put them together. 7x plus 2x, 9x. So some of the expressions will be very simple. Others will take a little work. Okay. Now, order of operations. Do things inside the parentheses first if you can. Can I put the a and the a squared together? The answer to that is no. Okay, so I'm going to have to find a way to work my way out. Now, the last section we talked about the distributive property. And so that tells me through multiplication, I can multiply each of these parts by 2. I can distribute this 2. So 2 times a is 2a. 2 times 2a squared is 4a squared. And 2 times 2b is 4b. Now I can't go any further because, again, I don't have like terms. I don't have the same variable raised to the same power. So this is as far as I'm going to be able to go. And just leave it right there and call it good enough. Now the order of these three things, again, could be switched around because if I wanted to, oh, I wrote them all together. Well, I could have went 4a squared plus 2a plus 4b, which is what you'd probably see in a textbook. But anyway, going on. X plus 4, can I do that? No, unlike terms. X minus 2, can I put those together? No, unlike terms, can't put those together. So now I'm going to go, as in the last section, I'm going to use the distributive property to my advantage. And I'm going to distribute the parts. 2 times x is 2x. 2 times 4 is 8. So I distributed the 2 through this first set of parentheses. I'm going to change colors here. 3 times x is 3x. Oh, plus. 3 times, I'm going to treat this as a negative. Negative 2 is negative 6. Okay. Well, now I have a new expression, and you'll notice that there are parts of this expression that are the same, or at least have the same variables and so on, so I can put them together. 2x plus 3x, the x's can go together, same variable, the same power, so that would be 5x. And then my regular numbers, if you want to call them regular standard numbers, can go together, so this is 8 minus 6 is 2, so, and that's a positive, so plus 2. And so in the last section we talked about the distributive property, where here's where I can use it to my advantage, knowing that I can use the distributive property to simplify expressions. Might take some practice, definitely will, well, you're going to do some practice, but might take some help. So if you need some help, if you get stuck somewhere and you need more me to talk through the whole adding like terms together and so on, then obviously come and see me, and we'll go over it further one-on-one. So, all right, good luck.